We're live. Let's see if there's already people trying to attend. Can you give it a try? The one in the Slack. So you got a special link.
I have a special link.
And you see me?
Yep.
Okay. Test 1, 2. Ja, dat is fijn.
Is dat een goed idee? Dat je dit...
Yeah, you cannot see it, right? Johan, you're going to the other room? I think otherwise it will interfere.
Okay, yeah.
Jovina is sitting next door.
Jonah is sitting next door. Before we start, maybe it's good to give you a little show around in our office. It's Hilke, Matthias. Say hi, everybody.
Hello.
You see the sun over the Amsterdam city and the canals. Okay, we're almost. Screen share. En dan moet je die. Dan moet je die als app installeren hier. App toevoegen.
Ik heb hem net wel. Hè? Oh, wacht, ja.
Okay, English. Hilke, can you close the doors? Because this is gonna... Okay, we're about to start. Just mute. Okay, just muted Johan. Let's see. I enabled the Q&A section, I think. Does anybody see the Q&A section? Have a look. Maybe it's because I use Google Apps. Okay, we're gonna do a bit more. It seems that because we use Google Apps, the Q&A section is closed, and we cannot get direct feedback from you guys. That's strange. Okay. Just a few minutes before we start, what I'm gonna do, I'm gonna make a topic on the forum. Okay, it seems that due to the fact that we're using Google Apps, somehow the Q&A section is closed, which is a bummer. What I'm gonna ask everybody is go to forum.thethingsnetwork.org. I put on a topic there, the Things Network Tech Update, February 29th. And you can put all your questions there. Actually, I think it's even a better option, because now we also have all the questions documented, and we could gather that for a Q&A. So go to forum.thethingsnetwork.org and go to the first article there, and we can get started. Somehow there's always something not working with this Google Hangouts, unfortunately. So the chat function is not there. If you just tuned in, if you have any questions during the presentation, please put them on the first post we got at the tech update, global tech update on forum.thethingsnetwork.org. So we're about to start. Today, we're already welcoming around 60 viewers, which is very impressive. And today we will be talking about our global tech update and telling you about what to expect from our new backend, the technology we will be providing, and also a short roadmap with regards to hardware and software. Something that I want to start off with is just a first presentation that Johan and I gave now already around 7 months ago, where we talked to an IoT community in Amsterdam and said our mission is to build a decentralized, open, and crowdsourced network. And I think today is also all about going back to that statement and telling you how we're gonna actually implement this in the coming 9 months. And that's the main topic of today, and also to get you all the information you need to help out and to get started with it or to contribute in any way. And yeah, that's about it. And I just yeah, Johan, can you take it from here and just kick off? Just again, the chat function is not enabled somehow. Sorry for that, but we're using a topic on forum.thethingsnetwork.org, and I will post it in a bit also in one of the comments. And there we will, you will be, you can post your questions during the meetup. So let's take it over to Johan. Johan, please kick it off, and then I will mute myself.
Hi, everybody. Hopefully everything works. Winky can give me a sign if it doesn't work. Thanks. I'm in the room next door. It's very good. So I'd like to give you a technical update about the progress of and everything we have been working on the past few months, and also our deployment strategy over the next few months up until August. So I have a short presentation, and as Winky said, we have a topic on the forum for everybody who just tuned in. Go to forum.thethingsnetwork.org and find the topic, the Things Network Tech Update of today. If you have any questions, please write your question there. I already see one question, which is very good. I will answer them, try to answer them during the call. Otherwise, we will send out a newsletter with answers to the questions that are raised during this presentation that I'm unable to answer right now, or that are raised afterwards. So now I'm going to share my screen, and let's see if that works. Screen share. Okay. All right. So this presentation is a technical update of this month, and I'm addressing the development of the backend as well as the timeline, which I will present in the end of this presentation. So we have a few design principles for those of you who are new to the Things Network, or that haven't seen technical update before. What we are building is an open, crowdsourced, and decentralized Internet of Things data network, which is compliant with the standards. We are compliant with the LoRaWAN specification, for example. We do everything open source, and we design for distribution and decentralization from the start. So that means that we are not, the Things Network is not an operator. We build different components, open source, standards compliant, to set up the network. And ideally, the data will flow to the application using the shortest path and not necessarily through our infrastructure. We also support small cells and therefore a very high capacity, very large number of devices. And there shall be no geographical borders. So the Things Network that is set up by a community in Amsterdam is the same as set up by a community somewhere else in the world, for example, in Brazil, where, and there will be no roaming, it will just work, and data shall be transferred through the internet. Also, we were compliant with spectrum regulations. As most of you know, the Things Network uses the ISM bands, and they are open and free for everybody to use. There are different frequencies around the world, but since spectrum is regulated, we have to comply with these regulations, and I will introduce the fair access policy a bit later in this presentation. So when it comes to cells, this is a screenshot of the current cells gateways we have around Amsterdam, and what it merely comes down to is that we want to provide the community insight in where the coverage is and where coverage should be added by the community. So, for example, if you have a couple of cells and looks like there are gaps, we are working with the community and setting up a social platform to encourage people to set up gateways in areas where there's no coverage. So this would add gateways in different locations. Also, if there are a lot of gateways near each other, there is a lot of overlapping coverage, and this may reduce the capacity of gateways. So therefore, we are building a system to reduce the cell size of some gateways so that we increase capacity per gateway. So that would ideally look like this. So when it comes to the core components, those are the cloud components that we are building as the core team of the Things Network. They are open source components, and we have, of course, the gateway, which is sends and receives data from the node. We have a router. Gateway send the data to the router. We have a broker, and the broker decouples the router from the handler. There is a network controller that remains the state of the node, does frequency management. Then we have an application handler that does decryption and works on behalf of the applications, and then we have the user application. So how this all stick together is on the left you see the gateways with the coverage and the yellow triangles representing the nodes, and they send data to one or two or other routers. And we are setting up routers as the Things Network Foundation, and they can be used free of charge, but everybody is able to set up their own routing infrastructure, which I will introduce later. So these routers, they send data to brokers, and this mechanism will eventually be a distributed network service discovery mechanism, which will be introduced in a few months. Currently, we are using a static forwarding mechanism using configuration. The brokers are connected to application handlers. So applications register themselves through the handler on a broker of choice. We are also going to host a broker next to a router as a foundation, and we will do this in various data centers around the world. And a handler can simply choose which broker to connect to. And the network service discovery will make sure that the data arrives eventually on the right application handler. Another way to get the data to your application would be by using a existing cloud platform. The Things Network is not going to provide an Internet of Things cloud platform. We believe that there are already many good ones, and we prefer integrating with existing cloud platforms instead of developing our own Internet of Things cloud platform. What we are developing, however, is integrations with these cloud platforms and also support for Node-RED. Node-RED is an open source tool developed by IBM, which allows you to prototype applications, or you can even use it for production using a drag and drop environment. It's pretty cool to use. Another way to use the Things Network is by setting up your own handler and using the storage handler. This is also an open source component that we will build, and the storage handler will store all the data that is sent for your application, and this will be something you can set up in your own infrastructure. So you can install a handler with the storage handler, and you have the database. So you will control the data, and the data will be stored physically in your own infrastructure. Another way to use the Things Network is setting up a private network, and the private network would be installing all the Things Network components on premise. So you can set up your own gateway, send the data to your router, and the router will communicate with the broker and the handler and the storage handler and your application, which will all run in your own data center. So this is a true closed private network solution with the same open source components as we provide in the cloud. The Things Network will also provide fallback mechanism in two ways. For example, since the protocol we use, LoRa, is a radio protocol, all the data is received by all the gateways. So this means that if you install your own gateway, you will still receive data for other applications on your gateway. So this allows routers that you have installed in your own infrastructure to send data back to the community. So this would send data optionally back to the community, and that works in two directions. So that means that even if you set up your own private network with your own gateway and all the components in your own infrastructure, you can still use the community network as a fallback mechanism, and your coverage will also be coverage for the community. Regarding cloud platform integrations, we are, since we are not building our own Internet of Things cloud platforms, but rather integrate with existing cloud platforms, we are building integrations with If This Then That, IBM Bluemix, FileWare, Amazon Web Services, Microsoft Azure, Node-RED, OpenSensors.io, and the Things.io. Since the Things Network is an open source project, we invite everybody to contribute to integrations, or if people want to build integrations with their own cloud platforms, then please post an issue to the Things Network GitHub, as I will introduce later. So the private networking is going to be very easy to set up. We will make Docker images available and we will maintain it. And again, private networks fall back to the community coverage and vice versa. The fair access policy is a policy that is required to be compliant with the spectrum regulations and also to make users reliable use of the network. So what we want to do is we set that we want to support at least 1,000 nodes per gateway, and we have to also take care of the duty cycles that the gateway has. So the gateway has to have enough time to receive packets, and that means that after some calculations, we have our network architect Thomas has done some very good calculations together with other experts in the LoRa Alliance to come up with the fair access policy. And what we're now proposing is that every node will get 30 seconds of airtime per 24 hours on average. And this means that every node will be able to send whenever it is required, and still a lot of messages, but it really depends on how big the payload is and what the data rate is used, how much time it will take per 24 hours to actually send these messages. So for example, if you want to send the temperature of your of a sensor to the Things network, you can use a JSON string, and this is something we've actually seen on the network. So it includes a counter and includes a temperature value, but this is not really efficient. This would take 40 bytes, and that means with 30 seconds of airtime per day and the highest spread factor, the smallest spread factor, sorry, will take up to 300 messages per day. If you would make it more compact, still JSON, it would decrease to 11 bytes and more messages per day. Without JSON, which is not really required, you can send even more or just 2 bytes. So we are encouraging people, application developers, to use binary encoding. This means that you're using less time per sensor per day, and this will eventually make the system more available to other users. So the timeline is as follows. We're starting next week with the world tour. We're going to South by Southwest with a workshop. We're going to Singapore. We're going to Tokyo. We're going to the LoRa Alliance meeting in April. March 24th, we will set up the staging environment for everybody to use. This will be a very rough environment that will be continuously improved over time. May 25th, and that will also be the start of a transition period of the current demonstration and prototyping backend. May 25th, the production environment will be available, as well as the Docker images and a web interface, a dashboard to configure everything. June 27th, we will ship the products for the Kickstarter, and then the end of July we will introduce distributed networking, and end of August we will take the current prototyping and demonstration backend offline. So regarding contribution, if you want to help us, of course everybody is welcome to contribute. We have the Slack, we have a forum, GitHub issues. Also check out our issues if you want to contribute. We do everything in Golang, and you can also sign up for our newsletter. Let's see if I have any questions. I just saw one thing, just for a complete view of what we are doing. We are supporting not only uplink from the nodes to your application, but also downlink and over-the-air activation. So we'll support LoRaWAN fully. Also, a difference from the current demonstration and prototyping backend is that currently all the data is open. We use one network key and one application key, which is fixed. With the starting from this new backend, of course, we will allow personalization with custom network keys, as well as application keys for over-the-air activation that will remain secret to your application. one of the key features of the Things Network is that we support true end-to-end encryption. That means that the Things Network doesn't have to know your secret app key. So data that is encrypted on your nodes by the software you have running on your device will be decrypted by the application handler. But since you can set up your own handler in your own infrastructure, for example, by installing a private storage handler or setting up a private network, the router and the broker, which will be run by this foundation, will pass encrypted data as is. So I'm going to see if there are any questions. Again, if you have any questions, you can go to the forum. We have a topic, and let's see if we have any questions. There was a question which is already posed by Simon Chappell, whether the applications are fully federated and partitioned with respect to the visibility of sensor events. Yes, so the current demonstration and prototyping backend, it's just one big pile of data which is accessible for everybody. Starting from our new backend, which will be introduced end of March, as a staging environment, everybody can use all the security features that LoRaWAN provides. Let's see. What about having a single handler managing tens to 100 applications? Yes. Yeah, exactly. You can a handler there is an application handler for each application, but a handler process can work for different applications at the same time. So we, as the foundation, will also set up a hosted handler, which can be used also for demonstration and prototyping purposes. And this will be one handler that will be able to handle data from multiple applications at the same time. Then a question from Wibrand. If I set up my own network, how do I prevent that others receive the data? The private network, you can secure your private network as you would secure any services that you would run in your own data center. So you can install, like you install web servers, you can just configure a custom firewall. As long as you secure your own environment, then your data is secure. So it's not different from another other services that you would configure in your own data center. Since LoRa is a radio protocol, all the data goes through the air. That will mean that all the data will be picked up by other gateways as well. And the reason why this is still secure is that messages are encrypted. So LoRaWAN supports message level encryption. It's not that nodes really pair with a specific gateway. They just simply send encrypted data, and if you have the right security keys, you can decrypt the data. What security are you implementing? You must register before it's allowed on the network. Yes. So you have to register your application, and with a secret app key. And then if you use over-the-air activation, then your node will activate itself for your app EUI. It's a 64-bit unique identifier for your application. And then the handler will accept this device or not. And it will be optional whether all devices will be activated or whether you want to restrict certain devices to activate. Another mechanism to use would be personalization, and then you would provide a list of devices that you already configured, and then you need to configure the device address and the network session key in the device, and then you have to register this list of devices, and then they are allowed on the network and you will receive the data. Let's see, another question regarding the 30 seconds airtime per node. If you want to run your own gateway, well, the 30 seconds fair access policy is, of course, it's a configurable value. Since all the components are open source, everybody is able to set up their own infrastructure and adjust this restriction. But the reason why we chose this value is because we have to comply with the spectrum regulations. Also, chips will, especially in Europe, in the certification, they require a limit of how much data they can send. So the duty cycle is enforced by the chip itself. So even if you run your own gateway, you can adjust these values, but that will not be in the benefit, and you will violate the spectrum regulations. So that is why we came up with these 30 seconds. Then a question from Arjan, also regarding the fair access policy. Whether it's possible to regarding the confirmed uplink. So confirmed uplink is a mechanism in LoRaWAN that enables nodes to get a reply from the network whether this message has been handled successfully. So it would be not only sending sensor data, for example, but also waiting for a confirmation from the network whether it has been successfully processed. And this would mean for each uplink message there would be a downlink message. But since the gateway also has a duty cycle, there is a limit on how much downlink we can support. So this is also a restriction. Confirmed uplink will not be possible for all devices, and this means that application developers should be careful when using this feature. Let's see, another corner that you throughput will increase. So let's see. Yeah, so the fair access policy is more. By the way, the fair access policy is more based on the gateway limitations than on the limitations of an individual node. So that's regarding the question from Manolis from Greece. Regarding the LoRaWAN multilateration, so the localization by nodes. We are waiting for updates from Semtech. Semtech announced a few days ago an update on this. Currently, we have no data of when and to which accuracy we will provide localization. We will provide an update on this soon. I think in the coming weeks. Problem is that the current hardware is not accurate enough to determine the timestamp of the time of arrival of an individual message. So that means that the accuracy of the localization is very limited or not accurate enough to actually use in practice. But this is something that the LoRa Alliance is working on, and we are also contributing to this. And we are doing our best to support localization as soon as possible. Regarding question from Andres, the serialization of data. Yes, there are different mechanisms to serialize data. One of them is indeed the protocol buffers from Google. And Google, for everybody to check out, is very interesting. Google protocol buffers allows you to define a schema of your data and then simply serialize and deserialize data to binary and back. This is something we encourage people to use. There are also other techniques to make it easy to serialize binary data. And this is also something that we will provide in our cookbook. It's the content of with the getting started and things to help developers make the data as compact as possible. So again, we recommend people to communicate and to serialize everything in a binary format. There are different ways to do this. You can just concatenate all your values, or you can use mechanisms like Google protocol buffers. Let's see, question. Yeah, question from Christoph Silski, virtual gateway, how to test. While waiting for the gateways to be shipped, we have a test gateway components on GitHub, and this would allow you to simulate traffic. It's not very easy to set up, but please, if you have any questions, if you want to set up a virtual gateway, please reach out to us using GitHub. Let's see, the question from Romain. How to the registration of the application on the handler. So we are developing a application dashboard. This is a web interface where you will be able to configure an application on the handler. I think in the staging environment that we will be making available end of March, sorry. So in 3 weeks. I think it will be either a very rough web interface or it will be an API. But there will be an API available, and this will also allow custom dashboards to be developed or apps to register applications. Let's see, 2 questions. One, Ben Ward, will you allow addressing to operate in blocks by application rather than location? I think I'm not really sure about whether I understand this question. So Ben, if you can clarify, please. Will you use allow? Yeah, of course we will. Regarding whether we allow commercial applications, the routing and broking service that will be provided by the Foundation will be free for everybody to use, and this will also enable commercial applications to be built on top of the Things network. There are no conditions for using the Things network as long as it complies with the fair access policy that we are rolling out. One note also regarding the fair access policy, we understand that it's quite a restrictive policy. Still, if your application sends the data in a very compact format, you can send hundreds of messages per day. So for most use cases, it will be sufficient. yeah, so let's see. Say that there comes with timestamp. Is it possible to tag with 3 or more access points? Yeah, so Vibrant, regarding the localization, indeed the localization is based on triangulation. That means that you would need at least 3 gateways to position a device. The problem here is that the accuracy, the two things. One is that the clocks of these different gateways should be precisely synchronized. And the other problem is that the time of arrival of a message cannot be accurately determined today. But Semtech released a new reference design a few days ago that fixes this problem. So that means that with new hardware, apparently there will not be a big problem. But this is something that we follow, and their parties in the LoRa Alliance are working very hard to solve this. Let's see. Okay, so I see a lot of questions on the fair access policy. I think what is best is that this is a short tech update presentation. I think Thomas and I will publish a more extensive document on the fair access policy somewhere next week, probably. Yeah, that should work somewhere next week, on the fair access policy, the reasons behind it, and how it works in practice. Then a question from Kulno Kaskula. To many applications of multiple users simultaneously. Yes, data sharing, that's definitely something that we want to support. So the Things Network, the components are open source, the gateways are shared, and they all form together one big network. I think for a lot of use cases it also makes sense to share the data itself as well. This is up to the application developer if he or she wants to share this data. We are working with an integration with OpenSensors.io, and OpenSensors.io is a website where you can publish your sensor data for everybody to use. So this could be a way to do this. Another way to do it would be to make your security keys public, and this would allow everybody to access your data. Thanks, Ben, for clarifying your question. I understood that addresses allocated to devices are on box. Is this true? Okay, yeah, I see. This is a question about the allocation and how we provision addresses to devices. It's a bit technical, but the way it works with the LoRaWAN protocol is that there is a 4-byte device address, and this 4-byte device address can be reused between devices. It's not like an IP address where it should be unique. In LoRa, they can be reused by multiple devices. The way the network distinguishes two physical devices is by the network session key. So if a packet comes in from a specific device, and there are two devices registered in the network with the same device address, there will be two network session keys, and only one will actually fit the message and will pass the message integrity check. And passing this message integrity check will make sure that which physical device it is, and then also which application handler will be able to decrypt the payload, which is one step further, which is done by the application handler. So the device addresses, the way they are currently allocated is that people can claim a block on our wiki page. Well, this is just for demonstration and prototyping. When using personalization, it will be possible to provide any device address with your custom network session keys. So you can just pick any device address. As long as it starts with the first 7 bits, that is the network ID, and the network ID is a fixed number that will identify that this is for the Things network. Then the device address for over-the-air activation will be generated by the network. So in short, for personalization, you can just provide any device address, and as long as you provide the network session key, the network can determine that it's your physical device by performing the message integrity check. Are there any added limitations for deploying network in the US? No. The fair access policy is a global policy, so it takes into account the limitations of the spectrum of various regions. And regarding, in general, the deployment of the Things network will be possible because there are also the ISM bands supported in the US, but they are a different frequency. So in the US, it's the 915 megahertz frequency. In Europe, it's the 868. But there are no added limitations as compared to Europe, for example. Then a question from Steve Karmansky, and that is currently the last question I see on my screen. Does this mean that you can have anonymous users or devices? How does it fit into regularity of Comcom's Act in the UK? So I'm not really sure what you mean with does this mean, but if you you have to register your application on the broker, and with registering it, it's just basically registering a name, a contact email address, and a unique app EUI. And we can also provide you with a unique app EUI because we have a block from the IEEE. The devices are provisioned by the users. So the way it works is that once you register your application with your unique app EUI on a broker of the Things network, then your devices can be activated. That devices with this app EUI are activated by your application. So yes, it will be anonymous in the sense that individual devices or individual users doesn't have to be registered on the Things network. All right, I think these are the questions so far. Let's see. I think if you have any additional questions, please post them in the forum topic. Also, we will draft a document with the stack update with the slides and also some background information about the fair access policy and what it means in practice. Please, thanks all for watching. Let's see, Winke, you're still there?
Yes, yes. Yes, I'm here. So, yeah, thanks all for watching. And I think one of the most important things is that the 24th of March will have a staging environment with a full stack of LoRaWAN implemented. And as Johan said, yeah, please help us out in testing, in reviewing, in whatever. We could really use your help. And you know how to reach out to us through Slack or to the forum or through email. So yeah, just want to finish with that call to action to you all. And I think that's about it, right, Johan?
Yes. Thanks everybody for watching.
Okay, bye.
Bye bye.